In this video, I'm going to discuss the reactions that can take place at the benzylic position of the aromatic compounds. So in a benzene derivative, the benzylic position are those positions right there. Now, reactions are going to be fairly common at these benzylic positions for two reasons. One is you have the resonance provided by ring, so it'll help to stabilize products or reactants. And two, it's an sp3 hybridized carbon. And you've learned in organic chemistry a lot of different reactions that take place at these sp3 hybridized carbons. One common reaction used at the benzylic position is the oxidation of that position to a carboxylic acid. So that's going to take place with potassium permanganate. So say that's my reactant. If I react it with KMnO4, so potassium permanganate, along with water and heat, my product will be benzoic acid. Well, technically it won't be protonated immediately, right? But then I can just add in acid or water to protonate to benzoic acid. And this reaction takes place regardless of how long the alkyl chain there is. So it's a very useful reaction to convert a fairly non-reactive, right, alkyl chain into a more reactive carboxylic acid. However, for this to happen, there needs to be a proton at the benzylic position. So if I were to try to do the same reaction with that as my reactant instead, I would get no reaction. Right? There's no proton at the benzylic position right there for me to be able to oxidize that position. Now, another common reaction with the benzylic position, and one that's very important, is free radical bromination. For this reaction, I use a source of electrophilic bromine, NBS, right, and heat. This will undergo a free radical mechanism, and I'll add a bromine to the benzylic position. Now, this is an especially useful reaction because bromide is quite reactive, whether it's going to be in an SN1 reaction, right? We could take our compound here that we just formed. I could react this with, say, water, and I could proceed via an SN1 mechanism to get that as my product, right? Because water is a weak nucleophile, so it'll undergo SN1. Right, that's another thing that's happening at this benzylic position. Because it's sp3 hybridized, you can have many reactions that you would have with alkyl chains can occur at this position. Again, because it's an sp3 hybridized carbon, you can get the reactions that you would have with an sp3 hybridized. So an SN2 reaction, SN1 reactions. If you have alkene groups out here at the benzylic position, right? So if I have something like this compound, I could have reactions that you'd see happen with alkenes over near the benzylic position. So a lot of different reactions can occur at this position.